Hi, Michael Wolf, PGI compiler engineer. Here we're going to be talking about two improvements to the Tesla managed option for the PGI OpenACC compilers. Managed memory is memory dynamically allocated in the system memory in such a way that the NVIDIA CUDA device driver will automatically page the data to the GPU when it's referred to on the GPU side and page the data back to the CPU as necessary. This can simplify life, particularly when you're doing your initial port, because the data directives for that data aren't so important. The data will be moved automatically by the device driver, so you don't need to tell the OpenACC compiler to insert the data movement or to put in the update directives as necessary. The problem is, this can affect performance quite a bit. The allocation itself is actually quite expensive. If you have a program that does a lot of allocations, particularly C++ programs, where you have a lot of dynamically allocated small classes, then the cost of the allocate can really affect the execution time of your program. With PGI 17.7, we have a new implementation that alleviates this overhead quite a bit, and I'm going to demonstrate that here today. So we're going to be running on two identical systems. These are dual socket Haswell systems, each with 16 cores, 32 cores total, 64 threads with hyperthreading, each connected to 2 Pascal GPUs, although we'll only be using one. I'm going to be building and running the OpenACC SpecExcel SP benchmark. This has an outer timing loop that does an allocate. It calls a subroutine that allocates an array every time through this loop and then deallocates it. So there are many, many allocations and deallocations. I'm going to build this program actually 3 times. In the upper window, I'm going to build it with the normal T equals Tesla option, and because it's a Pascal GPU, I'll be specifying compute capability 6.0. While that's building, in the lower window, I'm going to be using the PGI 17.5 compilers and building with the Tesla managed option. I'll be running the reference data set in each case. In the upper window, that's the normal case, the default build. The lower window is the managed option with the PGI 17.5 compilers. And what's immediately obvious is the lower window is running a heck of a lot slower. The lower window is running slower because that managed memory, it's allocating and deallocating that array every time through that timing loop. And the allocate and the deallocate is simply expensive. So the upper window here is going to finish momentarily. It takes about 30-some seconds, 35 seconds. The lower window is still running quite slowly. Let me rebuild this now with the 17.7 compilers and the managed option. And I'll rerun the ref data set, and it's going to be significantly zippier. So here the program is built. I'm running the ref data set with the managed option. The 17.7 compilers in the upper window, and you can see it's zipping along pretty well. In fact, I expect it to catch up and pass the execution on the lower case. The way we implemented this is using what's called a pool allocator. The OpenACC runtime allocates a large pool of managed memory using the CUDA runtime API. And then it sub-allocates your arrays or your data inside this large pool. So the expensive cost of allocating managed memory is only done once for the pool. And the sub-allocates are really quite inexpensive. So here you can see that with the PGI 7.7 compiler, the execution time with managed memory is roughly the same as it was using explicit data transfers. Whereas with the 17.5 compiler, well, it took over 2 minutes. So rather than 35 seconds, it was over 2 minutes, almost 4 times slower. So what we've gotten with 7.7 is managed memory running as fast as explicit data transfers, as opposed to a big slowdown. Now, there are ways that you can modify the behavior of the pool allocator. In most cases, we expect the default options to be satisfactory, but for those of you that want more details, there are some environment variables. There's 4 environment variables, which I will just briefly mention what they are, and you can experiment as you need to. There's the pool alloc, By default, this has value 1 when you're using TA equals Tesla:managed. Setting that to 0 will turn off the pool allocator. So if I turn off the pool allocator and run my PGI 17.7 compiled version, it's going to start running very slowly. We'll just let that one run in the background. The other option I have is I can set the PGI ACC pool size. That's the size of the memory pool that gets allocated. The default here is 1 gigabyte. On these devices, there are 16 gigabytes of memory. It starts with 1 gigabyte. If that fills up, it will allocate another pool of the same size. There's pool threshold. This is the fraction of the device memory, the maximum fraction of device memory that will go into the managed memory pool. The default here is 50%. So the default is 50. And the last is, what's the largest block of memory that will be allocated in the pool as opposed to explicitly allocated separately? And the default is 500 megabytes. That's a pretty large chunk of memory. So if you have huge arrays, well, pretty huge arrays will still be allocated in the pool. Thanks for watching the video for the improvements in PGI managed memory with the PGI 17.7 compilers.